and we have a very good lineup of guests whom you know, um, based on their previous broadcasts from Periscope and also here on HAPS. Um, so I'm gonna introduce everyone that's present at this point. We have Dr. Deanna Hooper, cosmologist.
Hello.
Um, we have Dr. Ian McLaughlin, a neuroscientist,
Hey, everybody.
and Isabel Betancourt, an entomologist.
Good morning, everyone. Good to be here. Thanks for organizing this.
Yeah. Thank you all for having. I know it's been difficult for all of you to kind of commit your time in order to dedicate a few hours, like a couple of hours for this discussion. And I'm really thankful that we were able to do so despite some limitations that we had. So I think we should probably get started with the discussion of the topic today, which is the human and nature interaction, and how it has how it has happened in the past, and how it's affecting us in the present, and the mutual uh, uh, the mutual interaction, if you will, in the future. So I guess it will be a safe way to start to at least from the past experience or from the past human nature interaction. So I think the best thing that I or the one of the ideas that I thought of will be a conversation starter is that why did nature favor a higher cortex, like a higher brain function above anything else, and why now? So, if anybody wants to give that a shot, or at least like try to have some kind of valid explanation, that will be a very good conversation starter.
I'm sure. I guess that's the closest to what I spent the last 10 years toiling in. Um, yeah, I mean, there's a bunch of we don't know for sure, right? There's a bunch of theories as to why it would be that human intelligence is just uh, so much more versatile than pretty much any other animal. I think probably one of the more widely accepted models is that basically through predator-prey interactions, where humans are not particularly strong relative to our primate cousins, significantly less strong than like a chimpanzee, for example, or a bonobo. And there's some interesting, biological mechanisms by which that occurs. But essentially, there's a trade-off. So we're not particularly strong. We're not particularly fast relative to prey. And so we had to either come up with some other adaptation to enable us to survive, or we would be outcompeted. And so that part of that was the ability to collaborate, to interact with each other in sort of complex social organizations, and that just sort of favored. There are a bunch of well, not quite spandrels, but there's a bunch of sort of ramifications for that, right? That social interaction requires a lot of complicated cognitive processes. I should say like complicated social interactions as opposed to just like reproduction alone. And so I think that's probably and so just any primate that was as weak as we are, but as social as we are, that sort of dynamic would favor the the continued expansion of human cognition. All right, I'll shut up now.
Yeah, that is a very interesting take. And Isa, would you like to add more? First, you have to unmute yourself. Okay.
Right. Thank you. I want to also comment and say to Scott over on YouTube that we can see your comments. All the comments from different platforms that this is multicasting to are aggregated onto the HAPS platform. So, but yeah, that was on my mind, Ian. And also I'll expand to say that one thing that's beneficial for increased intelligence is that all the tools that you have along with it. If a saber-toothed tiger breaks its teeth and it can't grow them back, like that's the end of the line for it. It can't continue on. So being able to make new tools and like put on a raincoat to go outside and weather the elements, or to get a hammer or a saw to build something new. Those are all really beneficial and things that animals, even like prosthetic legs that we can make. Like some animals have come to be able to overcome challenges like that, like spiders, which can regenerate their legs. But generally, like having the intelligence that we have allows us to create all sorts of things to help us adapt to all different kinds of environments, from going underwater to going up into outer space.
Yeah, that is a very also interesting take, Deanna.
Yeah, I was going to say, just going on what Isa said there about tool use, and especially with the example of the saber-tooth, breaking his tooth and so on. It reminds me of a comment or a discussion I was in once, as how do we define being an intelligent species or an intelligent civilization? And one argument that was made is, historically, it's the time at which we find records of the first healed femur bone, because that shows that humans actually stayed still long enough to care for a person with a broken femur, like part of a society, in order to really heal that person and progress, instead of just abandoning the injured one for the sake of the group. And that some people consider this to be a clear marker of when we actually became intelligent enough to adapt to our environment, to the point that we could survive past some of these, for example, broken bones or broken teeth. And this is something that separates us from a lot of other animals.
Yeah,
Deanna, I have a way, something that I think a lot of people would be interested in asking a physicist, right, who studies the cosmos. Do you have the perspective that human intelligence was inevitable given the conditions on Earth, given the condition, the place, the space that Earth occupies within our solar system and so on? Do you think essentially something like this was going to happen, or how do you see that?
I think so. Our planet does have the perfect conditions that we need for multiple types of life form beyond just a basic tardigrade or bacteria. We have the perfect conditions for this type of life. Now, of course, you need these conditions in order for such an intelligent life form to be able to exist. That said, it's quite likely that there are also a lot of planets with optimum conditions that don't have any life forms, or don't even have, especially not an intelligent evolved life form like us. So I think across a whole universe, it was an inevitability that we would end up with multiple intelligent species, just because of the ridiculous size of the universe. But as for on Earth itself, I think given the conditions, it was inevitable that there would be some type of life on Earth. But as for intelligent life, I think that's actually not a foregone conclusion. It's not necessarily that just because of the conditions of Earth, this is a natural consequence. I think there's a lot of that's had to happen that is a lot up to chance for us to actually be here having this conversation.
So I think it's also important to consider convergent evolution in this case, where it seems to have different kinds of animals developing some kind of higher cortical abilities, despite variability and speciation. So whether to ascertain whether that's actually the ultimate goal of life and the cosmos, that's probably difficult to say, because evolution is kind of like the governing rule when it comes to speciation. But I would have to agree with that it depends on so many factors, and there are so many variables that affect civilization, or not just civilization, but any species to evolve to a more collective civilization. All right, cool.
So Deanna, I mean, I guess I have another sort of question for Deanna. So, I didn't really study much, certainly not astronomy or cosmology, right? Just sort of like the intro physics stuff that I had to get through to call myself a scientist. And so excuse me, everybody. The way I sort of think about how, our solar system emerged, it is sort of through the lens of evolution, where, you have certain, composite parts that will have an inevitable interaction, right? And if you have the right parts, there's just going to be like an inorganic evolution that occurs, and so you'll get a planet here. It's entirely predictable. You'll have a planet here, a planet there, a big one over here, an icy one out there. You know what I mean? And so, is that like a reasonable dilettante way to understand
I think
how these physics play out?
So I think on one side, yes, because if you know all of the initial conditions and we assume you understand the laws of physics properly, you can predict any outcome. But the thing is, with the initial conditions here, you wouldn't just need to concern yourself about all of the objects moving within the solar system, which is already really difficult to account for. But like our moon was formed when a random asteroid came and crashed into the planet and basically ripped a chunk away. And this is something that in order to predict this, you also need to have an overview as to where that asteroid was. Same with the asteroid that wiped out the dinosaurs. Right? There are so many initial conditions. I think it's a similar argument to what you say sometimes, that if we could predict every interaction in the brain, would we have no free will? Would everything be determined? But there's just such a huge amount of interactions to predict here that we are not in any way capable of doing so. So at that point, it is a very good question of how much of the universe is actually deterministic and how much is random. We know that at the quantum level, there is randomness that you cannot predict. But on large scales, when you're dealing with planets, if you knew every single detail of the initial condition, you would be able to predict the outcome. But it's just such a huge amount of things you need to know that for us it's rather difficult.
Right.
If I can just incorporate a comment from somebody in the questions here, there was a question when we were talking about these other planets of would it be possible to visit these other planets? And I think that's potentially not for this broadcast. So maybe if you want to follow me on my own broadcast, we can discuss that in depth and how we would potentially visit these other planets and other solar systems.
Yeah, I guess we can probably touch that upon when we're discussing the future prospects of human-nature interaction as well, albeit like in a much more briefer way, like you just mentioned. So so I guess we also know that besides our complete dependence, even though we try to extricate ourselves from nature, we're still pretty much part of it. And what I see is that there are symbiotic relationships between us and nature, even though it may not sound evolutionarily incentivizing, but there exists some besides the regular nourishment that we depend on, like for example the crops that we grow and stuff. But like I said, there are some, especially like plant types that seem to have psychedelic effects or healing effects for that matter. Do you think like there is, to put it bluntly, if there is like an incentive for these plants to develop these chemicals to help us, navigate in our daily lives? Do you think like this is like an intended feature of nature? Anybody wants to give a shot at that?
I can comment and say that a lot of those like caffeine and other other chemicals like the spice that you get from hot peppers, capsaicin, are all things that are made by the plants for defense, so things don't eat them. And these chemical compounds they make will affect herbivores in all different types of ways. Like for me, I don't want to eat a hot pepper, so there's no worry for any hot pepper plant that I'm going to come over and eat it. But someone else kind of likes it, and so it definitely varies from person to person, and of course, species to species, because not all of them have receptors for those chemicals. But then there's also some, I don't know off the top of the head what species it is, but there are some plants that create chemicals that cause the herbivore to like get hungry really fast, or to like not get the nutrients that they need from the plant. Like there's all sorts of different things. And I think that I don't know specifically, and maybe Ian knows a little more about your question about psychedelics, but it affects, a lot of them will affect us. Like they're not made for us. They're made for the ecosystem that they're a part of, and to defend the plant from the herbivores that are in their environment. And then so when we go and taste them, like they'll react they'll affect us in different ways. Sort of like how with spiders, people oftentimes ask me like, "Oh, like is this spider venomous?" And the answer is like all spiders are venomous, but their venom, well, one, not all of them are able to bite us because some are very small, but then their venom will affect us in all sorts of different ways because some eat larger prey, some eat smaller prey, and some don't really rely on venom to subdue their prey, and some really rely very heavily on venom to subdue their prey, and so they might have more potent venom. But like generally, we're not a part of the ecosystem of spiders. They don't really need or want anything from us. So if we are to get affected by their venom, it's just it's not like targeted to us, and so it'll affect us in very different ways that are not really they're not targeted to us, I guess is what I'm saying. Yeah.
So Isa, one of my favorite examples of that is nicotine. So nicotine it evolved in tobacco to be an insecticide. I mean, nothing evolves to do anything, right? It just happened to evolve in tobacco, and it was favored because it prevented or at least some insects from consuming it. But of course, there's a lot of humans. Nicotine is probably one of the most widely consumed drugs in the world. Sort of weirdly, just because it's not a particularly rewarding substance, but to each their own. And it's been a very successful plant, evolving its symbiosis with the human brain. But one thing that I encounter a lot is folks who will make the argument that because let's take cannabis for example, right? Because cannabis evolved to have cannabinoids in it, that some people will perceive that as like, oh, well then, it evolved with us. It evolved to, we evolved to consume it, symbiotically, right? And it's sort of, that perspective is taking a step too far, right? Like, all life on Earth eventually can be traced back to a last common ancestor, right? We all have, many of the same genes, right? In terms of, comparing the human genome to, I can't remember what the classical one is, like it's corn or something. There's sort of like a shocking number of shared genes. And so when all of these animals and all of these plants are evolving from a sort of common, source, there's only so many combinations for novel genes, right? And so you're going to get instances where, you'll have a mushroom that evolved to produce a molecule that looks a lot like serotonin. And not because it was good for the mushroom for humans to eat the mushroom, right? But it just happened to evolve that enzymatic pathway to make psilocybin. And because we have this shared genetic heritage with everything, with every living thing, the likelihood that we're going to have a receptor, or we're going to have some molecule that's very similar to or compatible with these molecules is pretty likely, right? It's inevitable. And of course, it's important to keep in mind that like among the vast majority of plants on this earth, right, very few actually have, some kind of psychoactive effect, right? But some do. And it's almost just sort of like a game of numbers, right? Because of that shared genetic heritage. But yeah, nicotine is always my go-to example of like, something that is deadly to another form of life, but, at least moderately rewarding to humans.
Yeah. And yeah, thanks, Ian. The thing that you said too about how there's only so many different like combinations and chemical compounds and things like that definitely brings me back to one of my classes I took at Cornell, where we were looking at pheromones and the chemicals given off by different insects. And that was one of the things that came up. There's only so many different combinations in the world. I mean, there's a decent amount of diversity. We have a lot of richness and detail in our world, but there is structure and there is ways that molecules and atoms fit together that will come up again across different organisms.
Yeah, I think that's the thing, that if nature finds something that works, it's just repeated more often because it's successful. We see that at all scales throughout the universe. If a process or mechanism is energy efficient, it will be repeated. And it's true when you go down to protein folding, it's the most efficient possibility. So there is so much of this that is repeated just because it's proved to work in nature. So it's obviously nature's not like keeping a book of what works and what doesn't. But when things work, they're more likely to appear again. It's like the crab. I'm just always amused by this example that the crab has independently evolved about 7 times because it's just considered like an optimum form of evolution. So if in doubt, just evolve to be a crab.
And there are even spiders called crab spiders, which are completely different and unrelated to crabs, but they do have that form, very similar looking form to crabs. So
Those are all over South Florida, and like they look so strange. They're pretty small, but they straight up look like a tiny little crab. Like if you were to see it for the first time, didn't know that they exist, you'd probably think it's a baby crab. Yeah,
yeah,
that's great.
they're cute. And yeah, in biology, when it comes to organisms that end up having the same body plan for some reason, like I'm talking about how like bats fly with their hands and birds fly with their entire arms. We call that convergent evolution. They're converging because it works. Yeah.
Yeah, interesting. So yeah, I mean, it's kind of like fun to entertain all aspects of, um, at least like to trying to understand why we have so much dependency on natural environment around us, and I think Ian's point over the fact that there are so many genes that are mutually available even among plants and us is really something to hit upon. And Isa, and you also mentioned that there's always going to be like the path of least resistance, and the convergent evolution idea is a very much compelling and I think the best explanation that I can think of. Yeah, thank you for that. So again, like we're still kind of like trying to justify the past in a way, and I have a, a, a question for you all, and it has to do with something like uh, humans, especially like when human beings start to gather and form civilizations. There was a general consensus of trying to understand our place in the cosmos, right? And that's kind of like entailed by deification of different natural phenomenon, if you will, or trying to at least like justify ourselves or why we're here in regards to like a grand scale things. And do you think like that sort of affirmed or kind of like detach itself from our connection to nature, would you say? Or like if you have like other opinions, that's also acceptable. Uh,
Yeah, if I can jump on that question, I think it's really important as a species to remember where we come from and why we're here. And I think asking the question of why are we here is a way that keeps us connected to nature. Because you can say, why am I here? You can give the kind of scientific answer of I'm here because of thousands of years of evolution that have led to me being here, like thousands of combinations in the cosmos that have led to me being here. But that's not the type of answer we're actually looking for. But I think this question actually really roots us to nature and to our past and to like all of our ancestors before us, because this is a question that every human has always asked themselves: is where do we come from? There's the argument that is often made because we ask the same question on a much larger scale in cosmology of why is the universe here? Not just humans, but why is the whole universe here? And that's much harder to answer because we cannot look for a historical precedent. But it does really, I think, tie in together to how we always have this question of just trying to belong to something and trying to be part of something. And then we look for reason. But I really think that this connects us more to nature, especially when we look back into the past as how we got here. I think this is one of the ways we can stay the most connected to nature.
Yeah, no, you might remember this quote because I hope everybody will forgive me. I'm sort of my brain is mud right now because I just got my second vaccine yesterday as well. So I hope you'll forgive me. But there's a quote from I think Carl Sagan. It has a Carl Sagan-y feel, which is like humans are the universe becoming aware of itself, or humans are the universe contemplating itself.
Yeah, the universe
and
contemplating itself.
Yeah, right. And I mean, it's typically beautiful, as he is wont to do, or it's a statement that's beautiful as he's wont to make. And so, like with regards to like humans contemplating the universe, it's very unusual, right? But it could very well be the case that if you have the right puzzles or the right puzzle pieces, right, or the right ingredients, right, a pattern-seeking organism. An organism that has memory of some sort, that has some kind of complex social structure, you will inevitably, as more free time is available to humans, that organism or to the organism, that organism will inevitably begin, trying to understand more than just, how do I reproduce? How do I get food? How do I prevent my offspring from being murdered, or eaten, right? So it may, that's, I have to say, I'm predisposed to thinking of it that way. And as a result, it is very natural, right? It absolutely connects us more closely to nature than distinguishes us from it.
Isa, would you like to add something?
I really like what Deanna and Ian said, and I do think that it is really helpful for grounding to think about the whole past of like life on Earth, to how like we got to where we are, and when someone is wondering like about happiness and the meaning of life and all of that, to help ground yourself by looking at how humans came to be how they are and how fast in the last 100 years things have changed. And I think that's where it's so important for us to maintain a connection with nature and not get lost in our built up manufactured like world in our houses, for example, to jump to that part of the conversation. But
If I could add another comment following on with what Ian and Isa were saying there, especially Ian mentioned the importance of having memory in order to kind of ask these questions. And I think to me that also highlights the importance of telling stories to the next generation and listening to the stories of our ancestors and to the people before us. Because this common history that we can now pass down, that humans have always tried to like share our stories, I think this really helps set this continuity as life started on Earth, humans evolved, and throughout the history of evolution of humanity, we have been striving towards these questions of where we belong, where do we come from, how do we fit into this puzzle? And I think really getting this historical overview and these connections to the past also help tether us to history and to nature.
So, Deanna, I have a question that I've asked you multiple times, that you've been asked multiple times, that I've been asked many times, which is, you mentioned randomness, quantum at the quantum level, right? And you know where I'm going with this. Like, do you think that it is worth a scientist's energy to concern, or a neuroscientist's energy to concern themselves with quantum mechanics when trying to understand consciousness?
I definitely don't think so, because obviously consciousness is a very difficult concept to understand, but you can try to break it down to these interactions in your brain, right? But the problem here is that the quantum world is very, very much important when we're dealing with tiny, tiny particle levels. Once you've already moved on to a whole neuron, you're no longer at the particle physics level. This randomness that appears in quantum mechanics will tell you, which way an electron is spinning, but it won't tell you exactly how the plane works. So I think when we move up to bigger structures, what we call the macroscopic universe, which is basically anything bigger than 2 or 3 particles together, at that point, quantum mechanics is not the dominant process there. It really only plays a role for the individual particles. And most of the time, the behavior of one particle is not going to have any impact on the overall structure of the macroscopic system. So while there is obviously some randomness involved, I think at the level of studying consciousness, this randomness won't play a role, at least not the randomness coming from quantum mechanics. So I know there's also somebody who likes promoting the idea that we can affect the universe with our thoughts through quantum processes. That is also not something that can actually happen, because again, in the quantum world, we're dealing with these really, really tiny, tiny particles. So anytime we move to anything bigger than 5 or 6 particles together, we don't need to really concern ourselves about quantum mechanics.
Thank you for that. I will officially be referencing this conversation probably every single time I go on the internet. So I appreciate it.
Yeah.
It's a question that comes up often.
Yep.
And it is understandable. I mean, it's an understandable thing to contemplate, just because, if our fundamental building blocks, if there's a degree of randomness there, then, does that scale up? And then therefore, if we're made of these quarks and muons and all these lovely terms for quantum particles, then, are we ultimately random? But anyways, sorry, Abyss, it sounded like you were going to take us in a new direction.
Well, yeah, so I was going to probably segue from this, based on some of the things that you touched upon. And I guess, like, when it comes to, memory formation and, or at least like our ability to discern our place in the cosmos or in nature in general, we seem to be like, at least like justify some of the things that we do. Excuse me. And one of them is domestication, right? So there are some theories out there which have been floated that seem to claim that it's plants that actually domesticated us, not the other way around. Or when it comes to animals, like it's also like, as if we are like the followers of these natural causes, or other beings that we share this planet with. And one of the rationales that's been given was that like some grains, for example, have more genes and their DNA. Although, like, it depends on like which ones are going to be expressed. But to put it bluntly, like, they have more complexity than we could ever imagine. So I guess, like, I'm kind of like wanting to present this idea of domestication to you all, and you think like it's nature that domesticated us. I mean, I'm including everything that's not non-human at this point as part of nature, but or do you think it's the other way around? Because there are some, like I said, there are some instances when it comes to crops that seem to have that sort of tendency, but we also domesticated farm animals, pets, and whatnot, and we profoundly changed their genetic makeup as well, because they are, you know, very interdependent with our livelihoods, and we mutually affect each other. And do you think, like, so to put it, to wrap the whole thing up, do you think like there's this nature that domesticated us, or the other way around? I just wanted to have your take on that.
It's a really interesting question, and that's obviously quite critical to evolution. But something that I'm interested in, sort of also adding to this to the table here, is I am curious, Isa. So Isa has bugs, right? She has pet bugs, and she has threatened me with them before. Not really, but has convinced me to hold one. And I'm curious, are there examples of like bona fide domestication of an insect, right, as opposed to, like a dog, right? The level of domestication and symbiosis, between humans and dogs is sort of legendary. It's probably the best example. Not the only, certainly, but the insect nervous system and insect behavior it's just going to be simpler, right, than more complex animals. And so I'm curious, are there any instances of that where like a spider can like recognize you, or at least show signs of some version of recognition? I think you're muted.
The standard issues in all Zoom calls this year.
Oh no, looks like we lost you. At least your audio. Well, I will let her... I will let her figure that out while maybe getting to that topic.
Am I back? I'm back.
Yes, there you are.
You're back.
Cool.
Yeah, there you are. Good.
All right. I accidentally unplugged my mic when I was unplugging something else. So, okay. Yeah. When you were asking about, when you said, will they recognize you, you mean like me versus another person? Okay.
Yeah, exactly. Like, oh, this is Isa. And, it doesn't have to be like human recognition where it's like, I know what your face looks like, when you're not around, like that kind of thing, that level of recognition. Just sort of like, maybe it's through odorants of some sort, if it's like, I recognize the, molecules that this entity puts off. And I will therefore react differently to this entity than I would to another one that puts off different molecules.
Right. To my knowledge, no. And I have two different main thoughts with that. Well, one, there are two insects that are considered domesticated. One is, I'll let everyone think about it before I say what they are. So everyone have some guesses in your head. Okay.
I've seen your broadcast enough that I know the answers.
Yeah, I brought this up a couple times. That's a popular topic. One of them, I think I'm wearing it right now, is related. Silk. Actually, I don't know if this is silk. It might have some silk in it, not sure. But silkworms are one insect that's been domesticated. Definitely doesn't fit into the they can recognize you category, but it's an insect that humans, it's like livestock in a way. Like we take care of them and for generations and generations, and we've caused genetic modification of the way that they operate in their natural history. Need to double check this, but I believe one of those changes that have occurred from humans working with them is that when the caterpillars make their cocoons, they make it with one single strand of silk rather than like it's not broken up or anything like that. That way, when people go to collect the silk, it just is one long single strand, which is much better to work with. And then the other one is honeybees, which is very important agriculturally in many places and also falls into sort of like livestock category. This is definitely a topic that's also been discussed among like tarantula owners and things like that too. Like the whole idea of like, do they know who you are? And so they trust you, or can you train your tarantula and things like that too? But because sometimes they'll get frightened and stuff. But in my opinion, when it comes to tarantulas, I have 5 spiders. I think that they trained me. I listen to them and look at their body language and know how they react to things and get better at working with them because I'm in tune and listening and responding to the way that they're responding to me holding them. So I think I'm trained by them, but they're not domesticated either, I would say. Yeah, just still very wild. Yeah. I think Deanna said she had a note to say about this too.
Yeah, just I think it's also a very interesting question as to at which point. So what animal size do we think that they can actually recognize us? Because I think all of us would agree that a dog can differentiate between different humans, but as you say, tarantulas probably can't. So I think it's very interesting to ask where that limit is. Crows, for an example, are extremely intelligent birds. They can recognize faces, and the whole murder can recognize a face. If you wrong a crow, all of the pack will hate you. So just don't annoy crows. But one example I'm thinking of is we actually had a pet python for a few years. Very pretty orange python that we had. And depending who was holding her, her behavior would change. It's like when my dad would pick her up, she would go and sit on his neck and put her head on his ear and just like stay there very happy. But anytime I would pick her up, she would just stay on my arm. She wouldn't go up to my face, probably because she knew that I didn't really feel comfortable with that. So, of course, it could be just reading different tiny signs in our body, like heat signatures, detecting an increase in my pulse, something like that. But it very much did give the impression that this snake could differentiate between different people. So then it really raises a question to me that I don't have the answer to, maybe some of you do, as to at which stage in animal evolution or what size of animals or brain power do we think this ability to recognize different people actually sets in?
Yeah, it's an interesting topic. I mean, we know that recognition in humans, as is typically the case, is very complicated, right? And we know that there are different components to recognition. So, for example, somebody can have a stroke that damages a part of their brain called the fusiform gyrus, and they can acquire what's informally called face blindness. But they can still recognize people, right? So this is a part of the brain that is devoted to like understanding, making sense of somebody's face, distinguishing, my facial features from, whatever somebody else's. But there's more to recognition than just that, right? And so people who have this face blindness, again, typically after strokes, they develop other strategies for recognition, right? So they'll recognize people by the shape of their bodies, right? Or their overall demeanor, or their voice, or their hair. And so, clearly you can sort of disaggregate components of recognition. And so if that's the case in humans, right, then throughout the rest of the animal kingdom, there will be elements of, of how we recognize things. And then, of course, distinct ones, like, probably the most obvious one is pheromones, right? So humans there's an argument in our science, a very contentious one, that humans aren't very sensitive to pheromones. I've done a whole thing on this. There's some really interesting studies that suggest we may be a little bit more sensitive than we think. But it's, uncontested that, other animals, most other animals, even other primates, are far more driven by pheromones. And so each animal will have a unique, odorant. Pheromones are basically just molecules. You can think of them sort of like hormones, but they're just sort of molecules that your body produces. Oftentimes as a function of, the status of your immune system, certain components of the immune system. Interestingly, and I would just be, I think it's worth recognizing that actually, some of the studies that suggest that humans are responsive to pheromones they focus on human attraction. And so it turns out that, certain men will find certain, and this is it's both heterosexual and homosexual studies now, will prefer certain individuals with a consistent sort of pheromone component. And so while it's sort of like one of those things you don't necessarily notice is happening, this is a contentious claim. But anyways, so let's just stipulate that we're not really driven by pheromones very much. We can disaggregate all these things: facial recognition, body recognition, voice, etc., right? Personality. And so if that's the case, then there will be simpler versions where I just recognize you by your odorants, which is why that's the one I brought up with insects. Or arachnids, I guess. And so I guess the point I'm making is that it's going to be a spectrum, right? It's not just going to be like you either got it or you don't got it, right? That's at least how I think about it.
Yeah, interesting. So, Isa, I have a question for you. Do you think like the ant-aphid relationship can be categorized as domestication?
That's a cool question. I would say in some cases, like the dandelion aphid, I feel like the answer has to be like yes in a way. If it's if we put ourselves in the place of the ants and how that system works, that's pretty much seems like how it is, because with the dandelion system, those aphids, they need the ants to go there and clean up the honeydew. Otherwise, they would get stuck in it and it would cause major problems. So they have formed this really intimate relationship and they're reliant on the ants at this point, and the ants benefit. And I'm not totally sure if I think the ants are probably fine without them, but it's my understanding that the aphids are not fine without the ants. So I guess it depends on really how you define domestication or versus a mutualism, or there's all different types of relationships that organisms form with each other. Yeah, it's definitely an interesting question.
Yeah.
And
Go ahead.
I was just going to say, for people not familiar, a lot of ants have relationships with aphids where the aphids, they're tapped into plants and suck up their juices, but since plant juices are very liquidy, the aphids are often having to siphon off and create a lot of liquid or dew, or basically pee, very sweet and tasty and sugary droppings, which the ants love. And so because of that, oftentimes ants will be tending to these aphids and fending off any predators that are coming to bother the aphids. So they protect the aphids like cattle or something like that. And then they also get this benefit from the aphids. And it's this really interesting relationship that crops up in many different species of these organisms.
Yeah, interesting. I mean, I would have to agree. The whole domestication thing. It depends on how you look at it. And for me, I guess it did make sense to say that whether we are completely beholden to nature or the other way around is kind of made sense to me on a very particular cases. But you all have mentioned very good points and excellent points that need to be discussed.
It's my impression that I took an ecological orchard class back at Cornell as part of I did double majored in entomology and plant science. And during the class, I was just so amazed at like how babied the orchard trees are and like how reliant they are on humans to protect them from pathogens and pest insect species, pests, bacteria and fungus, and they just like would not survive very well without humans because of how much we've, I suppose, domesticated and cultivated them. And so they're so reliant on us at this point, which was really interesting. And because I'd never really thought about like the orchard plants, like apples and pears and things like that. Like they're basically like the plant version of our domesticated livestock. Is the idea that came. I think that a lot of it just has to do. My impression is that it has to do with humans wanting control. Oops, my internet connection says it's unstable. Can you hear me? Okay.
You're good now.
Yeah. Okay. I think a lot of it has to do with humans wanting control, and where control using the tools, problem able to get that, and by solving problems. Oops. For some, is the connection okay now? Sorry.
We can hear you, but the picture is kind of like frozen, or is okay? You're good now. You're back.
Okay. Okay, cool. Hopefully it stays this way. But yeah, so a lot of, I mean, humans love to solve problems, and we love the challenges. We love the mental stimulation, and so it's just interesting the path that it's led us to, and like how we care for all these domesticated animals and domesticated plants at this point too, and a lot of them are reliant on us for their survival at this point as well.
Yeah, that is a very interesting take. So to build upon some of the things that you touched, so we're gonna probably fast forward to many years after humans started expanding and kind of like invading what used to be like a territory of nature. And for me, I guess like the emblematic situations that actually signify this is the advent of plagues, for example, like plagues that have not been part of the human experience that seem to have rather detrimental effect on humans. So do you think like as human beings start to expand and kind of like interact with others that seem to have like that seem to be situated on a very different locales, do you think that kind of I guess like do you think that has sort of like an adverse effect, if you will, on humanity, because we were introduced to numerous pathogens that seem to threaten our existence at one point? Do you think like by gaining more territories from nature, would you say that we have essentially been able to allocate more land for farming, for for raising crops and whatever? Do you think like that had sort of an effect on us, on like as if nature is kind of like doing a retribution, if you will, for invading its territory, or do you think like it did affect us in a way, like by introducing us to like these new pathogens and new immunities? I know I phrased it really strangely. I can repeat my question in a more succinct way, if that makes sense.
I think I have a sense of where you're going with this. Yeah. So basically, like, is there some kind of does the universe respond in ways to our impinging upon it, right? And are those responses, inherently going to be bad for us, right? Is that sort of kind of where you were going?
Yeah, exactly. So I was thinking of the those new like new pathogens as an example, but you're right. The gist of the question is pretty much on par with that.
Okay, yeah. I mean, the way I think about it is, just sort of like a pendulum, or what are those Newton's plague? What are they called? Newton's balls.
Newton's cradle.
Newton's cradle. That's the one. I just think of it sort of like that, where like, as Isa was acknowledging, like, humans are driven to command our environments. And I mean, I think it ultimately emerges from the elimination of unpredictability, because generally speaking, unpredictability can be good. Generally speaking, evolutionarily, it's probably not going to be good most of the time, right? You're probably, looking at a predator of some sort, or, a deadly insect of some sort that you didn't know was there. Just generally speaking, sudden events in evolution typically aren't like, oh, great, like somebody just dropped a big hamburger on my lap, And so, I just think of it sort of like that, like the physics of, lifting one of those, one of the balls on Newton's cradle. And you lift it because you want it there and it's not going to move, but then you let go, and then you get all these ramifications. And so like one, I think a pretty intuitive example is the emergence of pathogens, as you were suggesting, as humans began to live in denser and denser environments, right, more closely with other humans, but also with animals. And so you have the the rise of the bubonic plague, for example, right, where it essentially wreaked havoc on societies where humans were living in dense conditions, and in novel relationships with animals as well. And we hadn't developed the new strategy to control that environment of hygiene, certainly of medicine, and so that's the inevitable byproduct of those conditions. And so for me, it's not necessarily like it's always going to be bad when humans impinge upon nature or influence it or sculpt it, but there will be ramifications that probably are not going to redound to our benefit ultimately down the road.
If I can jump on there, I think it's really important. We've also mentioned several times this want of humans to control the environment and often not care about the unintended consequences, or not think about the unintended consequences. And I think there are many ways that humans and nature can coexist and can be mutually beneficial. This has been shown extensively by a lot of indigenous tribes that are protecting most of the world's biodiversity. But a lot of humans have this tendency to want to control every aspect of our environment and to force our own way on nature. Nature is not going to take what humans want because it's not the way it's designed. I think there is a careful balance to be done here. Of course, we do want to explore more. We do want to, in some ways, be in harmony with nature so that it's beneficial to everyone. And I think that's not the path that humans have taken, especially over the last 100 years, where we're focusing much more on the controlling nature rather than on profiting from nature while helping protect nature. And I think that's also a very important thing. Of course, now, as you're mentioning, we have these pathogens. I think it's partly because we're playing about with nature without really thinking properly about what we're doing. There are ways of doing it in a way that would be more beneficial if we just stopped and had the conversation of what are we doing before we just started doing it. And that's something that I think humans are very bad at doing.
Yeah, I totally agree. But so I'm probably an irrationally optimistic on about humans and human consciousness. I think we have all the requisite components of consciousness to do that, right? It's just that there needs to be a broader appreciation of it. Could be completely just sort of like enlightened self-interest, right? Where climate change or things like this, ultimately it will be bad for something that you care about, right? It could be bad for your offspring, it could be bad for you, could harm you. I'm not saying that that's the only way to think about these ramifications, but I think once for even people who are like, I do not care, like I just don't think about it, I don't care, I don't think it's real, whatever strategy they use to ignore those byproducts of our actions. Once there's an appreciation for that, for what happens to us as a result, then we can behave more prudently, and more with greater compatibility with our environments. So yeah, but I mean, I totally agree, right? We have a lot of work to do, right? There's a lot of room for improvement when it comes to modern humans, at least Homo sapiens sapiens.
Yeah, I think I would agree with you that I like to be cautiously optimistic about humanity, but sometimes it's hard seeing people consistently ignoring the way we're interacting with nature. Yeah, I think there are benefits between interacting. Human and nature, we're not designed to be kept apart. We are part of nature and we should interact with it. But I think one example that comes to mind for me is eating meat. Eating meat has been part of human history for centuries, for millennia. It's part of what we do. And there are ways to do this ethically, there are ways to do it without infringing too much on nature. But now we're at a stage where it's basically impossible to find ethically produced meat to consume. And I think then obviously, on an individual level, we're not going to change much with our individual choices. But I think we do have a social and moral responsibility to ask the question of what are my individual choices doing to nature and how can I personally affect it? Of course, we're not going to change how all of humanity is working, but I think we can individually make steps towards making this balance between humans and nature more harmonious.
I think you're absolutely right. And you know, you're right about, you know, meat consumption but that is not isolated just to meat consumption, right? As you know, you were implying, but it's a choice, right? We could, you know, do this, right? It would require probably government intervention, right? We're just not. Right, we're just deciding not to, or you know, we'll ultimately develop technologies that eliminate, you know, the involvement of animal consciousness, you know, artificial meat and things like this. But yeah, you know, I agree. Dana, I have a question for you.
Sure.
So it was a former broadcast that you'd done. I can't remember exactly which, but when you used the phrase like exchanging information, okay? And I'm curious what you mean by that. And this is, you know, in the context of the cosmos, not like exchanging information like we're doing right now, right? And so here's you know, a specific example. So you were describing the nature of the concept of heat death, right? And you described the fundamental problem of the distance between things, stuff, and as including the inability to exchange information. And you know, I know physicists can have some like interesting concepts of like what information can be or what it means. You know, that's probably distinct from, you know, my discipline. Not always. You know, there are some neuroscientists who have some interesting definitions of information. But anyway, so you know, so what do you mean by saying that like when the distance between celestial bodies becomes so great that they can't physically interact, that they're no longer exchanging information? What do you mean by that?
Yeah, so I think exchanging information is kind of the umbrella term we use for all interactions that we know and potentially interactions that we don't. This is everything from just like an electromagnetic interaction to exchanging heat. This kind of flow of heat or energy from one particle to another or from one body to another is the way that pretty much every process in the universe takes place. So anytime, if you push on the wall, there's some exchange of energy. When a planet is forming, there's some energy involved in this process. And all of the interactions that we know of are limited by the distance. They cannot affect points that are very, very distant in the universe. So if it reaches the point that objects are so far apart that these forces can no longer interact, can no longer act, that there can just be no way of exchanging energy. It means there could be no measurable change. It also brings down the question of what would happen to time at that point, because we often define time as a way of measuring the change between event A and event B. And time is what measures this difference of event A becoming event B, or so on. So if there's no exchange of information and nothing can actually happen, what does that mean for time? And that's a very philosophical question to get into, I think. But yeah, I use exchange of information as this umbrella term for all forces, all interactions, any way of one body passing any type of heat or energy or particle to something else.
Yeah, that, I mean, the way you had used it to sort of imply that meaning, and I think it's an interesting way to think about interactions. And like in neuroscience, you know, there are some scientists, usually kind of old school, that, you know, it's like these neurons are not exchanging information because it's not a complicated enough event. But anyways, okay, so now I have another literally galaxy brain question for you that you probably get every single time and that you probably hate, but what can I say? I feel like I got to ask. What came before the Big Bang?
Yeah, that is a question that I get pretty much every single broadcast, and it is an interesting question. And I think we're moving a bit off topic here, but it is a very interesting question. The basic answer is we don't know, because we cannot measure anything before the Big Bang, if anything existed before the Big Bang. But the more concrete answer would be that anytime we do a calculation or anything we do in the history of the universe, we start a fraction of a second after the Big Bang. So this initial event is not part of our model. So it's outside of our model. But it also we assume that everything kind of began at the Big Bang, space-time included. So what came before the Big Bang is both a question that doesn't really make sense, because it's like asking what happened before time, and what does before mean if you remove time from the equation. But on the other hand, it's also something that we simply cannot answer from a scientific point of view, because all of our equations, all of our models, all of our theories start this fraction of a second after some initial event, and then we just move forward with it. But as to what triggered this initial event, if anything, or what came before, if there even was a before, is not something we can really answer.
I dig it. I mean, that's a traditionally unsatisfying and frustrating answer that a lot of scientists will have to give. Ultimately, we don't know, but also, that and that's okay, right? That's part of being science, is being comfortable with the unknown, and maybe even being excited, motivated by it. It's sort of like, when somebody's asking for a really parsimonious and succinct answer of like, how does the brain generate consciousness? It almost at a certain point, you're looking for, it's a nonsensical question. You're looking for something that need not exist or need not satisfy your sort of aesthetic preferences for an explanation. So welcome back, Isa. Glad to see you back in the chat.
Thanks. Good to be here. And yeah, on the note of like having an answer that you can't answer sort of thing, definitely sometimes when I'm gathering information for the bug scope on like even the general biology of an organism that I want to talk about, like I go around digging in the literature and like find a dozen questions that are not answering, but just like making me more confused and just showing how complex this world is. And like, yeah, that's what it's like, searching around on the edge of knowledge. Yeah.
That's one of those things about scientists that, I think we have the stereotype of being arrogant and, conceited, and, we think we know everything. And the problem is that that's true. No, I'm kidding. That scientists are just, I think it's actually unintuitive, because the discipline is devoted to the creation of new knowledge, right? But generally speaking, to be an effective scientist, or to speak the language at least, you have to be okay with like, the reality is, I don't know. Yeah,
the reality is, it depends. All those sorts of
right.
answers that people don't want to hear. So much of the time, I don't want to hear it. I want a very clean cut answer. But that's also what's so beautiful about the world, that there's so much to dig around, and it keeps on, like, it's just a big puzzle.
That's also where you can really push, though, right? Because if you can answer the question, someone asks a question and you answer, I don't know, it's like, oh, let me go and try and figure this out. Let's go and try to investigate this. And I think we have to accept that we won't always have all of the answers, no matter how hard we try. But when we hit that barrier of I don't know, that's when the science can become fun, because then you have to try to figure out an answer to that question.
Yeah.
What that is it's a career opportunity.
Exactly.
And it's also what I think is really valuable about talking about science live, and being like brave enough to go into the edge of where we don't really know, and just like admitting it, because like in the past, a lot of, I think, science presentation is very polished, and all you do is you present what you do know. And so here, I think one thing I love about being live is to help like show people that we don't know everything in the world, and there's so much to still discover. And this is how we're going about doing it, also showing that process and talking about that process.
I think it's also very important, especially with live streaming, HAPS, Periscope, these things that we do, that sometimes we're going to make mistakes because we are live. We don't have a chance to look up the answer. And sometimes we might be sure that we know something and we state it, and then after the broadcast, we're like, wait, was that right? And it's happened to me more than once that I then add a comment to the broadcast like, hey, I explained this thing, turns out I was wrong, sorry, misremembered, here's the correct answer. And I
Yeah.
think that's also super important just to show everybody that, we are humans, we do make mistakes, and sometimes I'll say something that is not correct. And just because I'm a scientist doesn't mean you should believe absolutely every single thing I say.
Yeah.
We are people who can make mistakes, and that's going to happen when we're live streaming.
Yeah. Sometimes I wish I could put a little disclaimer that's like, what I am saying is probably right,
The best
but
of my
definitely
ability.
double check and other sources too, because I'm live.
No.
Yeah.
Abyss, I have a topic that I think you might be able to you might have some insights. So Abyss is well, I guess your background is in engineering, but as a result, you are far more familiar with the sort of state of technology, and so I'm curious, like, how close do you think we are to arriving at something like a general artificial intelligence? Do you think that that's possible? Do you think it's ever going to happen?
Yeah, that is a really difficult question from many perspectives, but it is been raised on in the AI sphere whether we're going to have like some kind of a generalized artificial intelligence. Um, the I guess if I have to say, I think like we're probably heading that way. I don't know. I cannot give you a ballpark of like when the artificial general intelligence is going to be present or is going to be made and kind of like abundant for use. But it is close, and the reason why I say that is because you've seen some of the accomplishments with the DeepMind group, like the AlphaGo, AlphaZero, and much more recently the AlphaFold. So what they implied, or at least like what they applied to do, is sort of design a heuristic algorithm, if not algorithm, but sort of like a heuristic solution to a more complex problem. So would you call that to be like a general artificial intelligence? That's highly debatable because the network structure itself is kind of designing an optimal solution for the problem that's been presented. But when you look at the general like artificial general intelligence, at least like the template that we have is the human brain, and the human brain is like a constellation of different actions taking place. It's not just about problem solving, right? So in that sort of way, I think like it will be a divorce from reality to claim that AGI, like the artificial general intelligence, is going to happen soon because there are so many difficulties that need to be overcome, and I think this also goes hand in hand with our discovery of like what how brain operates, because at this point it's highly contentious as to how a some bunch of neurons connected in a very subtle way can give rise to something so complicated as consciousness, even if we have, like, assuming that we have consciousness, and that's sort of like a given statement, because that's also debatable in some areas. So um, so I think like that the artificial intelligence group would go hand in hand trying to model the human brain, and there is like a kind of like a codependency with a neuroscience field or other studies that seem to like really study this in a more profound way. Like if you have an emergent behavior and like an ant colony, that will be a very good idea to design genetic algorithm, which has been the inspiration of these kind of things. And in fact, like even the neural network was kind of inspired by neuroscience. So, um, so yeah, I mean, there is no easy or simple solution to that. Even the experts are still debating upon it, like debating on the time frame or whether it's possible to do so or not. But I would say that we're probably going to have like a much more specialized AI, if not general intelligence. So you can have, say, an AI that's expert in driving cars or expert in identifying objects or like translating languages. So I don't know if it's possible to kind of like amalgamate all these different concepts into one general intelligence and form like the feverish dream of every data scientist or every machine engineer, which is to create a general artificial intelligence. Does that answer your question, Ian?
Yeah, yeah. I mean, I didn't expect you to say, "Oh, it'll be like March 17th, 2034." Yeah, I was just curious, like, well, yeah, it's just such a debated topic, and I just don't think that I'd really heard your perspective on it. Yeah.
I think it's
Yeah.
fun sometimes to see the perhaps dissonance or contrast, because we see often in the press, and it's a common question of artificial intelligence is going to be smarter than us. And then I try to play about with a machine learning network and give it a picture of a galaxy, and it tells me it's a donut. Right? It's like, this is not more intelligent than me. We still have a long way to go. And I'm always amused at that, because when playing about with like neural nets and stuff, the results are sometimes good and sometimes like, come on, I could do better manually. So it's often funny to think of a computer being at the point where we have an AI capable of doing all of these things that people are worried that it will be doing, and contrasting with what scientists have access to currently. It always amuses me.
Yeah. One struggle that I have is that when I upload a photo to like Facebook of myself, you know how Facebook automatically tags who's in the photo? It always tags my sister. I have identical twin sister. So I'm always having to go through and like untag. And especially it's especially funny and weird when it's like a photo of me and like my husband or something like that too. I'm just like, But yeah, I can't tell the difference between identical twins yet, which makes sense. But people can tell us apart, so it's definitely interesting to see the progress there. But also, I think like there's some categorizations that I think are helping. Like, I guess when I think of AI, I also think of one of my.
Oh no.
You're breaking up again, Isa.
Yeah.
Fortunate. I think your audio might be back, but your video is not.
All right, I shall. Maybe I.
Okay, I think you're good now. Yeah.
You think I'm okay
Yeah,
now?
I think you're
Okay,
back
I
now.
hope so. Maybe I can. Okay, so maybe if I have more problems, I can put up a picture of like myself catching a bug or something instead of video, or maybe that would help. But anyway, one of my favorite apps, iNaturalist, uses AI or like categorization to help identify help identify insects. And while I definitely am cautious that like a lot of like computer technology is going to like take us away from the natural world and we'll get lost and separated from it, some of it I think will be really helpful for increasing bioliteracy and connecting people with the world and giving them the information about what's around them. And so the apps like iNaturalist are really awesome for that. It's like Pokemon in real life. And I am very excited about its future and encourage everybody to download it around the world. So
Isa, I was listening to your comments. Yeah, I don't know if I told you this. I bug Isa about bugs occasionally, and I saw a little thing that looks sort of like a tick. And in Pennsylvania,
right.
ticks are generally not a welcome beast. And so I used an app. I used this like bug identifier app, and it was really good. Like it was right on the money. So yeah, I mean, that technology is like pretty impressive, and I use it for plants all the time. I also am a plant nerd, and it's remarkable, and it's all free too. It's a collaborative effort where humans are basically instructing this, algorithm, this image recognition algorithm, and yeah, so that was very cool. I'm sure you're familiar with many of those types of apps, but yeah,
Was it
it's cool
Seek?
stuff. Well, I'm sorry.
Was it the app called Seek by curiosity?
No,
Seek?
it was like Bug ID or something. I tried a couple, and one was clearly superior to the other. Yeah, I'll get you the name.
Okay.
My phone is over there. But
Yeah, I'm curious.
and and like the point you're making, I think is absolutely correct. It brings us closer to nature. Like I go on walks with my daughter, and we live in a part of Philadelphia that has a good number of really interesting plants and stuff. And I know plants, but I didn't a double major in anything related to botany or anything. And so she's learning, well, I'll just bring my phone, take a picture, identify it. Oh, that's an English ivy, or this is, a tulip, or that's a whatever, some other similar crocus, I guess is how you pronounce the similar looking flower. And so she's learning these things. She's being brought closer to nature through the use of technology. And I think it's wonderful.
That's awesome. Yeah, I love that, Ian. That and the ukulele that you brought in and have been playing with her too that I heard about.
Yeah, you have to hear. So the ukulele that she has is ridiculous. It's like one strings two tuning knobs, and so you can't actually literally tune it. It's like, I don't know why they would have made it that way. Yeah, it's so. I mean, obviously she doesn't really notice the difference,
Right.
but
Right.
yeah. In any case.
Yeah, that's cool. Yeah. So going back to the whole technology connecting people with nature thing, I think that there's so much potential to help people get the information that they need and want about nature so they can better work with it and appreciate it and not just bulldoze all the good stuff and then realize the consequences of it later, sort of thing. But the struggle, I think, with it when it comes to that is I guess funding and resources to get that information out there, because it's not because the wildlife, they're not going to pay for that to happen, for the representation to happen so that we can get to know them better. And so things are chipping away bit by bit. iNaturalist is great, and the museums and across the country and the world are chipping away at these sort of efforts. But it is very critical and crucial that we get to that point of balance, of course, and sustainability for world peace, purpose, and all of that.
I think on this topic, I think on this topic, there's also the other interesting consideration about what is the environmental impact of developing an AI. Because things like Bitcoin are currently having such a huge environmental impact that I don't think its creators envisioned the effects of it. Now we're talking about developing AI to help us also identify nature, but it is the question of how much is this counterbalanced by the environmental impact. I try to lead a very environmental focused lifestyle, and I do a lot of things that I can to reduce my impact on the environment. But at the same time, in my work, I have to run computer simulations that run for a week. And at some point, I computed what is the carbon footprint of one of my simulations, and it's ridiculously high. It's like the equivalent of flying across the world. This is just for one simulation, and then it's the question of, as a scientist who needs computational simulations for my job, how much is this actually going against the idea of reducing my carbon footprint? Right? And I think it's also a concern or a question that we have to ask as we're developing these AIs, perhaps to help us connect more with nature. Again, it comes back to what are the unintended consequences that we're not paying attention to.
That's super interesting. I never even thought to try and compute something like that. I have a related topic for you, Deanna. Given that we are, getting ever closer to more complicated artificial intelligences, and it's happening here, do you think, and this is sort of similar to the question of, do you think there's life elsewhere in the universe, but do you think it's similarly inevitable that there will be an artificial intelligence or something that we would consider to be an artificial intelligence somewhere in the universe right now?
I think absolutely. I think for me, there is no doubt that there are other life forms out there. The question that I think is also very interesting is, would it exist at the same time as us? If you consider the few million years where humans might exist, would an artificial intelligence or another intelligent species exist at the same time as us? Because if you have anything like stars are going to form at slightly different times, then you can also add things like if you're in close proximity to a black hole, then time will pass differently for different people. So there's this whole concept of what does it actually mean to have an intelligent species, and would it actually be one that we could communicate with in any way? So I think without question, there has been other intelligent life in the universe at some point. Whether it still exists at the same time where humans are here, I think is a very, very different question that we cannot answer, because it very much depends on when these different civilizations happen and how long they've had to evolve and how evolution happened on these planets. But then, of course, it is the other side of if you're at the point where you have an artificial intelligence and your species that can go out and cross the stars and go travel to other galaxies, and it's a question of why haven't we seen them? Because we would expect at that point to even see residues of these cultures, even if they existed in the past. So it is a very good question, and it does come down to, I think, the fact that the universe is ridiculously big, and we're in this tiny little corner, and we've barely explored our own solar system. So we're basically just looking at our doorstep and saying, why can't I see the rest of the city? I think
Right.
we are limited by just a small amount of our own solar system that we've been able to experience so far.
Deanna, so I'm a science fiction nerd, right? And I know you are actually, given that your namesake is from a certain TV show that has to do with
Yeah, my
the
parents
stars.
and that.
Deanna Troy, I believe. Yeah, and so one of the cool things that Star Trek's a great show. I never really got into it, but one of the cool things that they do, and it's just fun, there's many iterations of this in science fiction, is to imagine what completely different types of intelligence would be. Like, I think they had one episode where there's like a silicon-based, as a substitution for carbon, a silicon-based life form. And that Star Trek's certainly not the only or the first to have explored that, but yeah, exactly. Like, yeah, sure, there can be intelligences elsewhere, but like, it's almost presumptuous of us to assume that it would necessarily even be recognizable to us. But I think that there's good arguments again, to the contrary, that like, there are certain components that are needed for something to be intelligent. But anyways, yeah. Interesting.
Yeah. So
I was gonna say,
Sorry,
I like Scott's comment, like looking at a raindrop and seeing it contains no whales. I think
that's a really nice analogy.
Yeah.
Yeah, that is a great one. Yeah, so to add to some of the things that you have mentioned, I think the reason why we have surplus usage of like machine learning or deep learning techniques is because there's an abundance of data. So it's directly correlated to how much data has been gathered over the years, and that seemed to have enabled different applications, whether it's identifying bugs or plant types, and there seems to be like also change in the algorithm itself. Like nobody's using say a very antiquated kind of learning techniques like the Boltzmann technique or something. But what I'm trying to say is that the technique has also evolved with the computation that we have. But there is also an inadvertent effect, like as Deanna just mentioned, that that goes with training your data for a very long time, which is now the industry standard. And that by itself would also have some repercussions when it comes to the environment. And there's also talk about using the blockchain approach to develop an AI. So yeah, it's a very complicated thing. And speaking of training, by the way, I don't know if you guys heard about the recent iteration of the OpenAI's GPT-3, which is supposed to be like one of the most complex artificial networks out there. And it takes about, if I'm not mistaken, well above $1 million to train the model. So what it does is it goes through the internet and collects virtually everything. So if you just give it a theme, it can generate like a whole title, like a whole lots of pages worth of content for you just based on that title. And sometimes it gets things right for the most part. Sometimes it doesn't. I mean, such as machine learning, because like it's a very unsupervised way of learning things. But yeah, so the training itself is like it takes a lot of effort, and it takes a lot of resources, and by itself will have some some effect on or repercussions on nature, and and the way we produce energy as well. Awesome. So like we're like I'm crossing so many things off on my list here, and I think like this has been like I think important thing to mention, like during this discussion. Do you think like we've been fortuitous enough not to have like a very, um, s- uh, like an environmental catastrophe, if you will, or if we have evaded, asteroid impact, and somehow that has led us to live, a decent, level of like a decent civilization as we are today. Do you think like we've been fortuitous enough to, to evade these kind of catastrophes that have kind of wiped out previous species? And on the parallel also, like I would also like to ask if some of nature occurrences, like for example, volcanic ash, having some kind of positive effect on, like, growing crops and, providing nutrients or whatever. Do you think like, our whole civilization is kind of sculpted in a way to like in a way that's actually in correlation with, those natural disasters, whether they're from, like, the earth, um, or at least, like, volcanic activities, if you will? Or do you think that we've been fortuitous enough to evade, large asteroids that essentially ended the lives of dinosaurs?
Yeah, I
Like
know.
what?
Sorry, go ahead,
Oh, I'm
Ian.
sorry. Go ahead. No, please, Dana.
Yeah, I was going to say, there are so many ways the universe could just randomly decide to wipe out life on Earth. Right? There are so many different things in the universe, ranging from an asteroid to a close by star exploding, that could end life on Earth or completely reshape the whole evolution. So I think we are, in a sense, very lucky that this hasn't happened yet. Statistically, it is going to happen at some point. We know that at some point there is going to be another dinosaur style asteroid. It's just a question of when. It's not expected for at least, 1,000 years, but yeah, it can happen at any point. And then there's also the thing about how this impacts us as a civilized society or as a like progressing civilization, because we're heavily dependent today on electricity. If there's a random solar flare, it could completely wipe out the whole communication network of the planet. These are things that people know can happen, and there's really not much we can do to prepare for them. So I think our status as a as a like intelligent species is partly due to everything that's led us to this moment, but also very much luck because we haven't been in one of these life-ending scenarios yet, which we very much could be. Not to scare anybody.
Totally,
Yeah.
And I mean, I think that's absolutely true. But another way to think about this is that we also benefited from a cataclysmic event, right? Had the dinosaurs not, been sort of demolished by, an asteroid, evidently, we probably wouldn't have been able to evolve, right?
That's a great point.
The Earth was a fundamentally different place, and so out of catastrophe came opportunity. But I think, given the fact that we are pretty undeniably the dominant species on Earth, any kind of significant change to the status quo will, be deleterious to our own survival. So, yeah, and it's just kind of like an interesting thing to recognize that, like, we also benefited from, cataclysm.
Totally. I don't really have much to add, but yeah, I think we benefited from that, and who knows what the future holds? I don't know. I mean, there's climate change right now that we're going through, but it feels like a slow process, even though it's pretty fast for the Earth. And so it'll be interesting to see how it reflects in history too, for that reason.
Like one thing to also think about is, like, there are certain things that we can anticipate, like are definitely going to happen. It's just a matter of time. And, obviously my mind goes to biological sources of these kinds of catastrophic events. Oh, shoot. Where, the emergence of antibiotic resistant, bacteria, superbugs, right? That is going to happen, as predictable as the sun's going to rise tomorrow. And it's just, a matter of time. So we can either prepare for that prospect or, suffer the consequences. And fortunately, there are a lot of people who are working on it, but still, perhaps not sufficient. I don't know. We'll have to see.
And same with the current global pandemic. That was predicted, and only a matter of time.
And it's only a matter of time before the next one.
Yep.
Yeah.
Yeah, I think
unfortunately.
it's also a very important conversation as to how much we are not paying attention to nature, because there are warning signs that we're choosing to ignore it. As Ian says, we know that these resistant bacteria are coming. They're going to be here at some point. There are steps we could be taking already to try to curb this, but it's not so economically beneficial, and therefore it's not such a big deal. And it's the same with climate change. We know the solutions. We know what needs to be done. And it's just a matter of, are we willing to do it? Are we willing to sacrifice our current comfortable living standard that we have in the West in order to protect the whole planet? And unfortunately, we're not. And I think as scientists, it is also our responsibility to really remind people of how precarious life on Earth is. And, there are so many things that can kill us, or completely change the whole evolution of humanity. And some we can control and some we can't. And the ones that we can control, we really should be doing more about. And I think part of our responsibility as scientists is to remind people of this.
Yeah, it's definitely like a perspective of long-term thinking versus short-term thinking, and also like kind of like almost like, yeah, making the most of today and competition today versus longevity in the long run. So very definitely goes into ethics, a lot of ethics to discuss, and yeah, many ways this conversation can go.
Yeah. So
So,
I guess.
I'm sorry. Go ahead, please.
Oh, okay, sorry. So, yeah, you all touched upon like really important stuff, and well, one of the things that I see is that we're becoming, well, I mean, like at this point, it's safe to say that we're completely dependent on technology. So there's like one more disaster that can doom our existence, which is like say like coronal mass ejection, which is like this dense charged particle emission from the sun. If it hits us, I think it did also hit us like if I'm not mistaken, in the 19th century. Deanna can correct me on that one, but uh, its effects are going to be pretty much catastrophic because we're completely dependent upon technology. And also, like you all mentioned that the fact that we have been through this pandemic, and it may not be the only thing that we're going to incur. And there's also a looming threat of like drug resistant bacteria and whatnot. So that makes it far more complicated, that we have to thread very carefully when it comes to you know um, when it comes to planning and putting some things in action in order to determine our survival. Ian, you're about to say something.
Oh, it was just a different topic that Scott brought up. Had essentially the dinosaurs not been extinctified or eradicated, would they have evolved into something more intelligent? Of course, we don't know how intelligent many of them were, but I think we can pretty confidently expect that they weren't particularly intelligent. And it looks like he's just having connectivity issues. But I would be curious. A similar question is. Given enough time, would there be an insect that would develop some kind of more robust intelligence? Maybe on the order of like an octopus or something like that. So I'm obviously just speculating, but my suspicion is that given enough time, right, and given the evolving landscape on Earth, that there probably would be a fairly intelligent dinosaur. It's a huge category, right? And dinosaurs existed on Earth for a super long time, of course. But given the right circumstances, probably comparable biology, right? Like a dinosaur that's not particularly strong, not particularly fast, right? That hunts collaboratively. Then yeah, you probably get something a little bit more robust, a sort of like Jurassic Park type of situation. But Isa, what do you think? Do you think that there could ever be an insect or an arachnid or whatever that develops some more robust intelligence given enough time?
I could see it happening. This is probably not what people want to hear to follow up that answer, but I will say that there are wasps that are being studied here at the University of Michigan. I'm broadcasting from Ann Arbor, Michigan. And the Tibbetts Lab, they study facial recognition among wasps, and some populations of paper wasps, are able to recognize their own nest mates, and they're social, and they know, and like that's really interesting because some other populations they found in Pennsylvania were not able to recognize each other's faces. And so there's definitely facial recognition happening among insects, and like some researchers trained bees to play soccer and move like a little ball to get a reward. There's little things here and there. A lot of insects are largely controlled though by chemicals, like with the eusocial insects, like honeybees and ant colonies and termite colonies. That's largely, I'd say, there's a lot of, it's not much thought, but rather like it seems kind of a little robotic to me in the way that they all interact and respond to chemical changes and sort of communications like that. But then also insects don't live for very long. And so I feel like living for a decent amount of time really is important when it comes to intelligence, like the type that we're talking about when it comes to intelligent life forms. So there's definitely a lot to, I definitely get that question a lot though, like how smart are insects and things like that. And it's a topic I can only lightly touch upon.
So I love all animals, and I think all animals should be protected, with the exception of wasps. I just have such a fear of wasps.
I just need to get to know them.
And mosquitoes.
Yeah, last time I tried that, I got stung by one. Like, I love all animals with the exception of wasps and ticks. Those are my two. So the thought of an intelligent wasp is honestly very scary.
Horrifying. Yeah. But yeah, I mean,
just
when I look at,
protecting their babies.
Right. When I look at an octopus, right, these are highly intelligent invertebrates, right, that have a very, very different nervous system from humans, but are capable of quite a bit. And, insects, at least as of now, there is no nervous system in an insect that could host something like intelligence. But, given that an octopus has a pretty distributed nervous system, as opposed to a highly centralized one like the human nervous system, I could imagine, get a big enough insect, get a lot of oxygen around it, get a lot of food, and maybe it can live longer. I could imagine, seeing a big, horrifying spider that can solve problems, highly complicated problems, and form a formidable, social structure.
Yeah, there are jumping spiders. Some jumping spiders are rather smart. They're able to solve problems where they look at something on a branch far away from them, and they know how to go get their prey, and with leaving the sight of their prey, they look away and they still know what they're doing. They can still follow what they're doing, where many predators, they have to keep their prey in sight the whole time. So that's one unique example, at least one that we can relate to too, because they're very visual and we are very visual. And so I think that we as humans can really tune into does having a visual primary sense help contribute with intelligence, or just help contribute to intelligence that we're able to recognize, if you know what I mean? To solve puzzles that we are able to recognize. So
I think you're right about that. And I think vision is the one, because Indiana, I mean, perhaps you might think of some other element of the universe that's dynamic and changing, but light, I don't know if there's a better thing to use as an update on your environment than light. And so, if you're sensitive to light, you have some form of vision. And so as a result, it might be the case that you can't really get a highly intelligent organism if all that they're sensitive to are, chemicals floating around them, or, wafting around them, or all they can be sensitive to are vibrations around them, right? With, the auditory system. But Deanna, could you imagine maybe a different part of the electromagnetic spectrum, or a different, aspect of the universe to which an animal could be sensitive that would be superior to light and vision?
Well, I think it's also not necessarily just light and vision. There are a lot of animals that guide themselves using the magnetic field of the Earth. And it is still electromagnetic force, but it's in a very different style. I think that there are a lot of examples of animals that don't require sight in order to navigate. As to how that affects the evolution of, develop cortex. I'm not sure if light is a necessary condition. I get what you mean that, it's the best way that we have to know our environment. But I'm wondering how much are we biasing that statement by the fact that that is how we interact most with our environment. I don't know
Definitely a fair point.
if there's another species that could be around a star that is in a very different part of the electromagnetic spectrum, any type of visual process would have developed very, very differently. But they might also have other ways of interacting with nature that we don't really think about because of the importance we put on our visual stimulus.
Yeah, I think that like audio, like animals that communicate through vibrations, could probably be pretty good at solving problems because, um, uh, like they can tap and send and receive signals and respond accordingly. And I feel like that could be a whole area where there's intelligence that we aren't really able to recognize as readily because it's more invisible to us and more subtle to us. There are leaf hoppers, for example, that communicate on plants by tapping on the plant. And if I touch the plant, I'm not going to be able to listen into their communication because it's such a different magnitude, and that's not a primary sense for me. Yeah. But it's definitely really interesting to think about. Yeah. And
If I should say,
oh, go ahead.
go
Go
ahead.
ahead, Abyss. Yeah.
I mean, for me, I guess like cephalopods probably have like traveled on a meteor or something to Earth because they're completely different than any intelligent being that we see on this planet. It's their ability to adapt and their ability for complex thinking is kind of unrivaled, especially if you're living in a low oxygen environment, such as in oceans, and it's really impressive. As to how this thing, like how they are able to develop these complex networks. So I guess my final question to you all is probably like where to move from here, like where the future would takes us as as we're interacting and constantly molding the future, and do we see ourselves as sort of like in this stewardship position to preserve nature, or do you think that we're still going to have this codependency as much as we had back in our ancestral days? uh, I don't know if it was clear, but I can repeat the question.
No, I'm happy to answer that. I think going forward, we really need to have some conversations as to who makes these decisions as to how much we interact with nature. One example that comes to mind that I know is going to get me a lot of hate because it's always a way to trigger some people. We have this Starlink problem, these satellites by Elon Musk that are damaging the night sky. They are interfering with how humanity has always seen the night sky. And it's the question of who has the right to decide this for all of humanity? Who can make these decisions to affect nature to such a scale that every human is then affected by it to some degree? And I think we really need to sit down and have some important ethical considerations with many, many different voices and points of view at play here, because we are very much often focused on what's relevant for one person or for the people putting in the money, and not necessarily what's important for all of humanity and indeed for nature itself. So I think going forward, I do like to be cautiously optimistic about humanity. And I think we can do a lot. I do think we will always need to be in balance with nature because we need nature to survive, and I can't see that changing in the future. But I think we really do need to have some ethical conversations about a lot of technology, including things like gene editing, and how we're going to move out into the stars and visit other planets. I think for all of these things, we're not yet ethically and legally at a stage where we are with our technology. So the technology has progressed faster, I think, than a lot of us expected. But we really do need to sit down and have these conversations about what are the implications, because we've already ignored the implications throughout our history, especially in the last 100 years in the Western world. We've very much ignored these consequences. So I think we now really need to sit down and ask properly, what are we doing and how can we do it properly?
Fair point.
A source of optimism for me is that at least within the biomedical sciences, like that is happening a lot more now than it used to. Where like the person who invented CRISPR, Jennifer Doudna, a brilliant scientist in California. She, and she wasn't the only person to invent it, but she's one of the main people who did. Inherent to the platform was a recognition that this is potentially transformative. It's potentially dangerous. A huge ethical, framework is going to be necessary for us to survive with this in existence. And like, yeah, I mean, I agree. I don't think that ever would have happened, just a few decades ago. I think it just would have been like, boom, we made it. Now let's make, synthetic babies, and so I think that the scientific community is getting better at that. So at least there's that.
Yeah, I think that the internet will be very helpful with all of this in documenting and sharing our history with nature and with technology. Where in the past it's like, oh, this happened and it was bad, and then like on to the next thing, and it's hard to keep track of everything. I think that the internet will prove itself and has proved itself to be a really great tool for learning and reflecting and being better when it comes to the ethics of our technologies and the effects that we're having on nature. Yeah.
All right, awesome. So this kind of wraps up, I guess.
Will you repeat your question again? Because Donald was wondering again, and also.
Yeah, so I was actually wondering if the future, like if in like the future, assuming that we kind of survive this existential point, where if we become like spacefaring civilization, would that also, would we be also like codependent on nature as we used to, or do we have, or do we assume that kind of like the stewardship leader position, or cement our stewardship over nature for it to live on, if that makes sense?
Yeah. I guess I don't. My gut reaction, I guess, is that I don't like that question, because I don't like the idea of separating and going far from nature, because I think that life would be really boring without it, like really incredibly boring without the natural world around us. And like we like evolved with nature, like, and I think that I mean, there's a lot of people looking at how it affects like our mental health and things like that. And so I hope that those studies continue, and that everyone like is able to really do a serious reflection and understand and respect and preserve and protect that the legacy and of Earth and the nature that we're surrounded with currently, that's currently very, very, very under threat, and much of it disappearing, unfortunately. Not to go the doomsday or the sad route, but there are 1 million species of insects and many more millions to be discovered, and many of them we're never going to know existed by the time before. So many will go extinct before we even know they existed, and things like that are just like, I can go on and on, but I'll stop there. But I think unless there's a certain point to elaborate on, but those are some things that cross my mind with that.
Yeah, I mean, I should clarify also that the intention of the question was to kind of brainstorm, as opposed to like, trying to isolate ourselves from nature and seeing nature as like an inferior force. It's not what I meant. It's just like,
Yeah.
I just want to see if I just want to have some kind of prognostic, like the ability to prognosticate if we're going to have like such dependence on nature, even if we are like I said, higher level of civilization. I hope that makes sense.
Mm-hmm.
Yeah. So with that, if you have closing remarks, I would like to open it. Of course, like we're like nearing a 2-hour mark right now, but if not, we can probably close this. But if you have closing remarks, I'll leave it all to you.
If I can make a remark here, I think we've covered some really important topics, and thanks Abyss for setting it up. It was really good fun. But I think in terms of closing remarks, I'm going to echo something we've already said of just how important this connection with nature is and how important it is that we don't lose that. And I think one way that I found personally to stay more connected to nature is by seeing how other people interact with nature. For an example, I've listened to Isa's Hatch forecast so many times now that I go out and look for bugs. When I'm out on my walk, I might pay more attention to bugs than I did in the past. I follow a lot of people on Twitter who are in the birding community, and based on their enthusiasm for the different types of birds, I'm now paying attention to how the magpies are behaving outside my window. And I think when scientists share their enthusiasm for nature, it reminds us all how connected we should be to nature. And I think, yeah, my closing comment would be go and appreciate nature and surround yourself with people who appreciate nature as well, because it will deepen your own connection with nature.
Yeah, I think that's really great, Deanna. And yeah, I think just the whole, like, once again, like with the internet, it's this powerful tool for increasing the knowledge. And if we know more about what's around us and how it all works, we can appreciate it and we can value it more. Because otherwise, like if people don't understand and don't have a way to connect with nature, then like why would you save it? Why would you save it if you so that's I guess probably why all of us here are live broadcasting, because we want to connect and increase access to the wonders of the world. And yeah, thanks for hosting this, Abyss.
No problem. My pleasure. Ian.
So one other source of optimism for me is that, I have a 2.5-year-old daughter, just under 2.5 years old. And, what they say is, we're all born scientists. I've observed that. I mean, it's true. She's extremely curious, and most curious about what she sees outside, most curious about seeing different kinds of flowers, the smell of rosemary, the smell of, oh, does this thing smell? Does this thing smell? The different types of ivies, a lot of ivy here in Philly, different kinds of trees and so on. And so, I think part of the answer to this is just the reality that as we get older, I am privileged to get to devote my attention to the beauty of nature. And hopefully she will be too. And for many of us, more immediate concerns dominate. And, having the free time, the resources to be able to do that, it's not available for everybody. And so I think part of the answer to this is to mitigate that kind of those things that demand many people's attention, because then I think it'll be a lot more intuitive and likely that most people will recognize that, or more people will recognize that that these things are important, and they're important to our survival, and they're inherently beautiful and worthy of protection. Abyss, this was fun. Thank you so much for putting it together. Everybody should check out what Deanna has been doing. I think she's going to be doing something very soon. Isa as well. And Abyss, we've finally convinced Abyss to start joining in these conversations more regularly. So yeah, thanks everybody.
Yeah, and thanks to everybody who had interesting comments and has followed along with us for 2 hours. It's been fun to see everybody's reactions to what we've been saying as well.
Totally.
Indeed.
Yeah, thank you, everyone.
I agree.
Cheers.
Yeah, thank you for setting your time to have this interesting discussion. I hope this is going to be the first of many discussions that we're probably going to have. And yeah, I mean, thank you for dedicating your time, and thank you for the audience as well. I'd like also to thank Eleanor for producing this content, and everyone that has pitched in, for the awards. I really want to thank you for that. And with that, we're gonna end this live broadcast. Thank you, everyone. Have a good night. Have a good day or night.
Yeah.
Bye.
See you, everybody.
Bye.